Okay, so I'm going to extract, the information from this Excel. Okay, so I'm going to close it. Now I'm going to run. Yeah, I create a simple UI for this. Okay, so you can change the model. For example, you want to use GPT-4, you can replace it. And now I start extract. Let me open the simulation window. Okay, you see here, this is the complete message that we pass. It's starting to extract, from the response message. You see here, right? All this operation, you can reuse it. So if I open the system model, you see, oh, this is the system of interest. This is the requirement, the system, power subsystem, refine to requirement. So it means that there is a requirement fuel capacity here. Oh, yeah. So it will automatically detect this fuel capacity later. Inside our, we have function drive. This is drive function, documentation, the description of that function, refine to requirement emission, this requirement, allocate to a system, power subsystem, this one, and parameter. See here, fuel capacity. Okay, power subsystem. Okay, so I think it's ready for us to generate. So let's generate. Here, yeah, you will see here. Yes. Okay, so if you review, list of generate element is consistent with Excel now. Requirements. Yep. So for the function, this is the function activity.
Hello, Habibi again. So let's have the second part of our session about power of the scripting in CATIA Magic, especially in relation to simulation toolkit and SysML execution. So what are you going to present now?
Yeah, so the topic that I want to present today is about the importance of human in loop in doing any data automation for MBSE. So in here, in this demonstration, we will demonstrate two main scenario. The scenario is for without AI power. Without AI power, when we say AI, is of course you can guess is Gen AI or is LLM. And then the second ones we will demonstrate the other possible use case with AI. Okay. So yes.
What will be the main use case of application?
What is the main use case? What do you mean?
So data import and model creation or something like that?
Yes, yes. So it's a kind of like for the first part, it's more about the Excel synchronization. So from the Excel, for example, from the spreadsheet document like this, for example, if you had a name and also you have the documentation, or you may also have, like for example, another column for relationship, like refine relationship, allocate relationship, or certify relationship. You can automatically take that column and then create a dependency based relationship in Cameo, in CATIA Magic. Okay, so I mean the basic use case, mostly people only capture name or only attribute, right? But now with this capability, we can also capture relationship and create the relationship automatically from the column. Okay, that's that's the more advanced topic from our last class, our last master class. Because our last master class we only capture only attributes, right? But now we also capture relationship from Cameo, from the spreadsheet document. Okay, so now, so the things about the human in loop here. So basically, I want to try to explain the reason behind this demonstration. So this demonstration actually want to leverage the capability of of human in order to analyze whatever result that they might come from AI, right? For example, like from Gen AI, and then of course, if in order to use AI, especially the generative AI, we need to have human, and also we need to have the context. So the context or the pattern that that will be used by AI actually is can be captured inside the model itself. That is why we also want to positioning the power of MBSE itself to access AI, not only AI to access MBSE. Okay, so well, let's start with the first the first samples, right? So the first samples without AI power, I prepare the Excel extractor context here. So if you see on the top right, basically we prepare the context called the document extractor sample context. So this document extractor sample context is, for example, you define, for example, the name of the Excel that you want to synchronize or you want to import. I mean the information that you want to import. Like for example, in here I have the Excel system model for Excel dot XLXS. Yeah. So if I open this system model, this Excel file, so you will see this Excel file consists of multiple sheet. So for example, we have the system of interest sheet, and then we have requirement, and we have systems. So if you see for the system, we have name, we have documentation as the second row, we have refined to requirement, and after that we have the function sheet, and then we have the name, documentation, we have refined to requirement, and we have also the other column called allocate to system. And then for the parameter, we have additional refine and also assign to system. It means which system or which block that own this parameter, right? So this is actually what we define inside the Excel for the import, for the import or for the import, export, or for the synchronization, yeah, with Excel. Any questions about this first? No, yeah. So the job of this, the red block, yeah, the red block is for supervising, yes, to supervise all the sub, yeah, we call them sub agent. So this sub agent will handle different each of that sheets of the Excel document differently. Like for example, if you have different pattern, you can tell that this agent will handle system of interest, and then this requirements agent will handle the requirement, and then this system agent will handle the system agent, and then function agent will handle the function, and parameter agent will handle the parameters. Okay, so if you see here also, the knowledge or the context that we put on this on this context is the relationship or dependency relationship. It means that in order to generate, for example, requirements how to say a requirements element, we need to let the system of interest agent to finish the task first. So this dependency is a kind of like a sequence, dependency sequence on when we do the automation, right? So like for example, if you want to have a function and then function allocate to block or a function allocate to the systems, then we need to let the system agent first to finish the job, finish the task. And after that, we create the function and allocate directly that functions to the system or to the block. So this dependency is actually where we positioning, the MBSE, as the fundamental or as the, part of the knowledge when we use AI or when we do any automation. That's that's the, the story, yeah, one of the story that we want to tell. Okay, so if you click on this document extractor, yeah, function, is basically is a kind of like, how to say, yeah, reusable behavior. So behind this behavior is actually we prepare, for example, we prepare a kind of like operation. So this operation is actually inherit from the block or from from the block here. I call this block is generic element pattern. So this block is actually defined, for example, like you have the read method, you have the write method, for example, right? So in here, we want to only use the read method, right? So after that, you can have an agent that inherit from this generic element pattern, and then you can reuse that operation. Yeah, so if you have another context, that you can reuse that operation. So we have to create a kind of like, a dynamic, dynamic operation that can be reused in different agent, but you just need to pass, for example, different pattern. Like, for example, what is the first row, or maybe you can create a dynamic script that or dynamic behavior that can read the column dynamically. For example, if you switch documentation's position, like for example, documentation position to the left and name to the right, you don't read from the sequence of the column, like the first column, second column, but you read, for example, the first row first. Yeah, so you read the header first, and then you prepare a kind of like array, and then you loop by you do the looping by array, and then assign with the name of the name of the header, right? So that's how you avoid hard scripting. Yeah, so you use the header name or the column name. So yeah, so this is the the way how we prepare the context behind, and then you can use only one scripting that we put in the library in order to to reuse it in different type of context or different type of pattern. Any question first before we run the the document extractor? So if you see here, right, what we are going to do. So we behind this is actually we prepare. Let me show you. We prepare a kind of like pattern. Let I think under the tag. Okay. So if you see here, we have the target base classifier is class, and then we have the target package is this package. So later on, every system of interest, it will be only one, yeah, system of interest block. We will put this block under this package. Okay, that's how we do the mapping, yeah, for the positioning. And then for the requirements, if you see the requirement, you will see for requirement, the target base classifier is also class. And then the target stereotype is requirement. The target package is this requirement package. So you expect to have all the requirements will be generated here. Okay. So now it's the same, yeah, for the system, for the function, and then also for the parameter. Okay. So now I'm going to run the extractor. You see, all is automatically generated. So if you notice, right, why we have requirement under the function. So this case is actually happen. For example, if we have like for example, we have a function that allocate to the block, and then that function is refined to some requirement that might not exist or might not we cannot find it, for example, in containment tree. So we generate those temporary requirement. So later on, the modeler can start to looking, oh, for example, oh, I need the electric power generation requirement, so we generate those requirement under the function package, but later on we can move them manually to requirement, right? But this is detect based on the Excel that we have. So we don't try to break directly the relationship, but we still keep the relationship, but we generate new requirement consistently with the, consistently, for example, with the, the row. Like, for example, we need there is some requirement about power, or maybe we have some requirement for the electric power generation, for example. We still keep those requirements if that requirement cannot be found based on the human name under the requirement. So this is the pattern, or the pattern that we build, yeah, in the library operation, yeah. So in the operation library. So if you see here, let's see, like for example, from the list of generated element, we have the system of interest. So it's include the, the description under the documentation attribute under the comment. And then we have the requirement. So as you can see here, we have the requirement. And then we have the system. Okay, this is the system. Not only that, not only name and documentation, but we can also check if there is any refine. We should have refine here, right? Refine. Okay, I think we need to check that later. And then we have the function, list of the function, and we have the list of the parameter. So for the parameter, right, of course, we need to have a holder, right? Because consistently with the SysML specification, right? If we want to create a value property, it need to sit inside a block because it's a part of the structural feature of the block, right? So we keep, the SysML specification consistently. Okay, so now the other automation that we want to show, for examples, right? We have, let's say that we have this. I want to take this part, and then you can see actually the relationship that we get, from the Excel. So you see this refine. So this refine relationship is consistently with the, if we back to the system here. So we have the breaking and also the comfort here. Okay, so that's come from the Excel. So we keep, those, we maintain, the relationship as well. Okay, and it's not, it's work for any type of relationship as long as you can define, the pattern. Okay, so you will see. Let me try to take the other. Display the relationship. You see here. So allocate the function, allocate to the block. The function or the activity is refined to this requirement. So let me arrange this if you want to see. You see all relations is come. And then not only that, I will also take for the parameter one. So you will see, is there any relationship? No, I think to the those value, right? Yes, it's come. Okay, any questions about this before we continue? You are on mute.
Okay, I don't see the text in the requirements. Was that because the text was not present, or is it?
No, because
not?
because I provide a dynamic way to find, for example, if there is no existing requirement yet in the Excel. Like for example, I intend to show this actually, right? So for example, if there is a relationship to the for example, to acceleration, right? For example, like this. So we can, we can directly automatically create refine relationship directly to this acceleration based on the human name. Okay, so the things is you have to be careful with scripting. I also intend to show this type of mistake is if you use the scripting, you need to apply your own way, yeah, or your own way to detect, the same hit name. Like for example, from the application perspective, it's not allowable for you to create the same human name acceleration and acceleration like this. So you need to handle this, in upfront. So in your automation, you need to actually tell, right? So if you find any requirement under the same owner, like for example, who is the owner here, requirement package, you need to avoid or you need to ignore, or you need to tell the users that the important or the modeler that, hey, you cannot re-import this requirement. So we have two acceleration like this, right? You cannot import this requirement. You need to do checking, double checking if there is a same human name, like this. So you supposed not to do that. So you need to handle this, upfront. But of course, I can show you, how to do. Basically, it's a kind of like if else condition, right? So if there is a requirement exists, under the requirement package, under the same owner, the same owner, you have to ignore him, or you have to throw, a kind of like error, and then notify the user that this is actually is a double, or is a double requirement, because it's betray the SysML specification. So you need to handle this properly. So like for
Okay.
example, yeah. So because I cannot find that requirement, for example, like few range requirement, for example, from the containment tree, when I say containment tree from the whole project, so it means that I will generate a new one. Because you notice that, there is no fuel range. There is a fuel economy requirement, but there is no fuel range based on the Excel sheet that we have. So instead of ignoring the relationship, we still create the relationship, but we generate a new requirement based on the name defined in the Excel. Okay,
Okay.
this is actually to compensate, the human mistake when we put it in Excel sheet.
Clear.
Okay, so now that's for the Excel part, right? So the Excel part, I think that is also important to, because like this use case is actually very common, yeah, for the document, or for the Excel, advanced, we can say advanced synchronization to the Excel. Because for the attribute, like for example, name of documentation is very easy, right? You just use our default Excel mapping in order to do that, right, for the name and documentation. But the trick is when you include relationship, like for example, refine relationship, allocate, satisfy, right? uh yeah, you need to have, a kind of like, more advanced, behavior, more advanced scripting in order to handle, different type of problem. Yeah. So
So
now I'm
understood. So what about, for example, connectors?
connector. We can do it. We can do it. But the tricky part is, for the connector, it's not just a connector, but you need to also play with the role of the port. I forget, the specification, that part. So if you want to define a connector first, if that connector is directly to the part property or to the reference property, is easy. Yeah, but if you start to involving a port, that port you need to also synchronize with the type of that port. Like for example, interface block, or full port for the block for the full port, and then you need to also play with the role. I forget the name, the specification name for that, but there is a 2 or 3 layer that you need to work with the connector behind the scene. That, yes, we can do that.
That good addition. I know that current even we have like 6th or 7th version of Excel importer still struggles to handle connectors as you said, it's multi-level import
Yeah,
needed.
yeah. So
So this is
that's the
great next generation of import capability prototype,
yes,
let's say, right?
yes, yes.
Mhm.
For connector, you can do it, but you need to handle, I think, 2 or 3 layer. It's not just like a source and target relationship directly, but you need to handle the owner of the port. You need to handle the role of the port, and then the port itself, the connector itself have two side, and you cannot define what the dependency, like the source and the target, like that, because it's always have two sides, and then you need to handle those two sides dynamically. Okay, it's possible to handle the connector as well. Okay, so now, for the demonstration, right? I don't want to delete this manually, right? Because we will use an we want to have a fresh demonstration. So I also have the cleaner cleaner method here. Yeah? So if you clean this, right? Everything clean from the model.
That's
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 another that's another automation that I create, for the demonstration. Okay.
the motivation. It's the
I'm lazy. I'm
repeat,
lazy man.
repeat, yeah, repeat a task for capable, busy people to
Yes.
not repeat them anymore.
Yes. 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 So in here, right, I reuse the same. I use the rest same pattern. Like for example, for the cleaner, right, I reuse the same pattern. The stem structure, requirement structure for the requirement part properties, function, agent, part property, system, requirement, and after that I just pass those to one function called the remove all generated function. So because we have the definition of the target package here, system of interest package, requirement package, I know that that information is stored inside my model. That's why I call them MBSE assisted automation, because everything is already defined under our meta model, right? So why we not just reuse that in order to tell you what action you want to do, like write, read, or even remove the element, right?
Absolutely, absolutely, yes.
Okay, so next, this is the interesting part, yeah. So now, after we finish, right? So basically, we use the same concept, in the lower stream. We use the same concept. But the information on the spreads on the Excel side, we take it from the document, for example. So imagine that if you have, let's say that you have the document. I borrow the hybrid SUV document here. Is one of the common specification document for SysML specification. So I take this PDF file, and then from that PDF file, by using our scripting inside CATIA Magic, our behavior inside CATIA Magic, we extract those information, and then we pass them into the Excel. So here we not invoke any plugin. So we create everything is only script, yeah, it's only script, and then some operation, yeah, reusable operations under the block. Like for example, here if you see the generic LLM, for example, here, uh, we have we determine key, we determine what model, you determine the base URL, right? So later we discuss about this, this context later. So from the document, we extract to the Excel, and we continue from the Excel with the same use case that we just demonstrate, yeah, just now, to generate the system architecture, to generate the element, like system of interest, the requirement, the system block, the functions activity, and also the parameter value property, right? So we for the lower stream, yeah, we use the same use case, but we want to show the capability how to invoke operations, like for example invoking Gen AI API with Cameo or with CATIA Magic. Okay, so okay, so why instead of directly from the document, after you have the LM information, you not just directly to create system architectures, because if you see here, we introduce the human in loop. It means that after you extract the information from document, right, and then it show you in the spreadsheet, and then you can review that spreadsheet first, you can review that Excel first before you continue to generate the model. So we involve human to review first the result of the extraction from the algorithm, yeah, from the AI, from the machine learning extractor. Okay, so now let me explain the document extractor context here. So if you see here, right, we create, let's say that we create this, how to say, this generic block, yeah. So this generic block you can reuse later for different type of, different sample of different extractor context. Like for examples, in here you include, what is the model, what is the base URL, and of course you can create your own, context for the other engine. Yeah, for example, if you don't want to use ChatGPT, you can use, for example, like Mistral. You can use DeepSeek, right? It doesn't matter because you can use the same pattern, yeah, in order to use the, to use this LLM context. Okay, and then from there, we use the same pattern like what we show in Excel, but in this case, you see, we have more information. Like for example, what will be the response format, for example, for the system of interest. Like for example, for the system of interest, I want to have name, I want to have documentation or description that written from LLM, yeah, from the Gen AI. So you can define your own pattern here. Like for example, I want to have the name, I want to have the documentation, or maybe you want to have another attribute that you want to, you want to, how to say, include, yeah, in the when you generate the element. So for the requirement is also name and documentation. For the system block, I want to have name, I want to have documentation, and I want to have refined relationship to the requirement. And then for the function, name, documentation, refine, and allocate. And then for the parameter, you want to have name, documentation, refine, and assign to system or owned by block. For example, the block owner, for example, you can have, different pattern for each of the agent, right? So later on, based on this, the context that you provide here, we create, we construct the message before we pass to, to LLM API. So instead of, so from the user's perspective, yeah, you only see this message. Can you create a SysML model from the upload document? But based on the requirement agent that you based on the agent, yeah, the multiple agent you define and different pattern for each of the agent, right? You construct those messages like, automatically. So you can keep the message from the user perspective as simple as possible, but after that you can add, construct those messages, to constrain, yeah, the return result from the LLM. That's how you use information from the context itself. Even when you build or construct the final message, or we construct the complete message to LLM. Any questions about this? Any comment? Okay. So from
No
there,
questions, but ready for the demo.
okay. So here, right? So basically, this is the function that you can, you can reuse, yeah, when you create the, how to say, when you create the context. So here, of course, you need to have a send message with file, and send the response format. Like for example, you constrain the response format from the LLM. So you pass those to, LLM, and then it will return the raw response. The raw response is means that we extract, the string. Yeah, we extract the string from the string. In this case, we use the JSON format, yeah, that return from LLM. However, if it's not, is in the form of JSON format, we can put the constraint that, hey, we cannot extract, for example, any information from this format. So it will it will do again, yeah, it will redo again, the first function. So we can automatically detect those, abnormality by putting, for example, any boolean variable like is any extraction fail. So if there is any failure, during the extraction to the JSON file, for example, to the raw message, we can redo again until the LLM, for example, return the, the correct format. Okay. So after that, right, we write those and we pass those response to the Excel. Yeah, when we pass those to Excel, we use the same operation, we use the same pattern. We tell a requirement agent to please write to Excel, and then we tell the system agent to write to the system sheet, and then for the rest, yeah, the same operation, yeah, the same pattern for the rest. And then after we write it, we can post first. We can ask the user, the modeler, to review first the Excel. So that's why we have this decision node, right? So after we review them, after we correct them, if there is any mistake that generated from the LLM, then you can read from that Excel and in order to generate. So we will use the same the same pattern with the first from the first how to say, from the first demonstration. Okay, so now let me show you how I'm going to, don't save it, so I'm going to open an empty Excel, yeah, because we want to do the live demo. Yeah, okay, so let me open the Excel file first. Okay, so you see here we prepare name documentation. So this is consistent with the format, yeah, with the pattern that we prepare for each of the agent. So if you change any, then the pattern name, you need to also change here. It must be consistent. Okay, we have function, we have parameter. Okay, done. So this is, we prepare this, yeah, system model for AI .xlxs, yeah. So if you see here, I define those here. I believe that here, I define here, system model. So this is the name of the Excel. And then this is the location of the PDF file. So let me open. So this is the PDF file. Okay, so I'm going to extract, the information from this Excel. Okay, so I'm going to close it. Now I'm going to run. Yeah, I create a simple UI for this. Okay, so you can change the model. For example, you want to use GPT-4, you can replace it. And now I start extract. Let me open the simulation window. Okay, you see here, this is the complete message that we pass. It's starting to extract, the from the response message. You see here, right? All this operation, you can reuse it. So if I open the system model, you see, oh, this is the system of interest. This is the requirement, the system, power subsystem, refine to requirement. So it means that there is a requirement fuel capacity here. Oh, yeah. So it will automatically detect this fuel capacity later. Inside our, we have function drive. This is drive function documentation. The description of that function, refine to requirement emission. This requirement, allocate to a system, power subsystem, this one, and parameter. See here, fuel capacity. Okay, power subsystem, power subsystem. Okay, so I think it's ready for us to generate. So let's generate here. Yeah, you will see here. Yes. Okay, so if you review, list of generated element is consistent with Excel now. Requirements. Yep. So for the function, this is the function activity. Let's say that from the system architect perspective here. So I'm going to show the relationship that come here. I think let's see if there is any relationship. So there is a two relationship, allocate and refine here. That is okay. And then come over. So and then for the power subsystem, I want to see if there is any relationship from here to the fuel capacity. I think that's it. How many relationships we have? One. That's you extract that one from the PDF. And of course, for the details, right? For the if you want to have more information that extracted from the document, right? You need to train your model. Yeah, it's more on the LLM side. It's not depends on the the capability of the Cameo CATIA Magic extractor here, because the job of the CATIA Magic here is only pass the message and then process the written message to Excel file, and then from the Excel file to automatically generate the model.
This approach requires the simulation toolkit and opaque behaviors to execute the code. Do you use like some external libraries?
No,
No, you don't need any libraries, or
no,
is this
not
not
at
the
all.
problem? Not at
Not
all.
at all. You see
Mhm.
here, if you want to use a library, right, or is either two-way, right? You use plugin in order to encapsulate dot library, or you do under this simulation option. You see there is no external library that I use here. It means that it's just use Java, it just use a Java, library. So inside that, our library is also include the JSON parser there. We have JSON parser, and yeah, I think I use only JSON parser that already include inside the CATIA Magic use library. So you don't need to include any external library. Okay, so there's no plugin here. It's all pure, only scripting opaque behavior.
Of course, you don't need to install anything. You can distribute together
No.
with the project, right?
Yes. You
Yes,
can just
that's
distribute
the
this
big deal.
project.
Yeah, even this UI, people might not understand that it's actually built
Ah,
with
yeah,
CATIA Magic.
yeah. It's a CATIA Magic. Yeah, correct. So let me see. Let me show you. Where is that? I think I put somewhere here under the samples. Number 2, the output. I think here. Yeah, this is one of our capability to create.
Looks quite nice. I didn't even notice.
So if you see here, right, there is a boolean here, the flag. So this flag is any extraction fail. For example, during your extraction to the JSON file, if there is any failure, either in agent failure, or either in system block failure, you need to notify that, because if there is any extraction fail, it means that maybe the return message from the LLM maybe is not following the pattern that you want, right? So you need to handle this properly. Okay, so you can do that. How to do that is basically sit inside the logic, is sit inside here. So for example, if there is any extraction, like for example, requirement agent fail, so it means that if any of these fail with the you put all condition there, it means maybe it's impacting the whole processes of the element generator. So you need to handle all of this when you do any optimization. So yeah, so it's a it's a one of best, I can say that best capability of CATIA Magic and Magic model analysis.
SysML v2 will introduce easier way to do the same, or it will be similar?
To me, SysML version 2, I expect to be easier, because SysML, we can train the LLM directly to understand the semantic. So in SysML version 1, you need to have encoding and decoding, but in SysML version 2, you will expect to have minimum encoding and decoding. But here, because since you deal with the with the natural language, you need to have semantic between semantic mapping between the, or to say, SysML specification and also the LLM response, string response, the natural language response. So you need to map them. So how I map them, of course, you can use CSV format, or you can use JSON format. But of course, for industry, I think that it's better to use a kind of like JSON format, or better than you use delimiter like a new line or semicolon or colon. I think it's not consistent, not consistent. I think JSON is more consistent to map between. SysML version 2, from the specification that I see, I think it will be easier. But of course, you need to train first LLM to understand the meta model of SysML version 2. That's I think the challenge here.
Yes, you're right. You're right.
Yeah.
That's,
It will
that's
take
like
time. It
also,
will take time.
will go with time, right? More models, more easier to create correct
Yes.
SysML v2.
Yes. Okay. So what's next
Okay.
topic, Saulius?
Okay, so thank you for this master mind session version 2, and let's go forward with the progress in excited agent-based simulation of automation,
Yeah.
and
So
see what next in the next
yeah,
lesson.
I
Thank
think
you.
one use case that we can think after this is actually more about the layer prompting. So imagine if first you ask the questions to LLM, like, for example, please extract the requirement for me from this document. And then from after you have the list of the requirement, then you use that list of the requirement for the next query, for the next prompt, right? So it's like a dependent layer form, right? So from the requirement, you ask the question about requirement, and you use the output from the first query as the input of the second query. So it's layering. So you can handle all of that layer dynamically with different agent that you construct in CATIA Magic in SysML. Can you imagine that? This will open many door for how actually you have to use LLM, not just blindly use them and then take whatever written from the LLM, but you guide the Gen AI, you guide the LLM in order to give you a better result. I will not say you remove the hallucination, but it gives you better result because under your guidance. That's why it need to be supervised. Thank you, Solis.
Okay, thank you.
Thank you. Bye-bye.